Now let's do something that's complicated. That's right, you just started freaking out. Okay, it doesn't change the process just because there's a lot more reactions. There's just a lot more things to look at. So it says determine the heat of formation of liquid hydrogen peroxide. Okay, again, a formation reaction is elements combine together to form a compound. Now specifically, we're looking for liquid hydrogen peroxide. Now normally sign is not very important, but because there is both gas and liquid hydrogen peroxide, I must be specific about which one I'm doing in this problem. Okay? Now something else I want to tell you before you get started is O's and O2's are not the same. Okay, so make sure you cancel the exact same things with each other. So pause the video, do your little math, and come back and see if you got it right. And I'm going to solve this now. Okay, I want to make sure that I have my H2O's on the left. My H2O liquids on H2O2 liquids on the left. So I'm going to flip this reaction. And I multiply this by -1. Okay? Now, now I look at this, these other ones, and I say, okay, well, I've got a lot of excess in here. I've got H2O's, I've got O's, I've got H's. I got to get rid of these. My H2O2 gases will now cancel because they're on opposite sides. But I notice that I've got an H2O gas here and an H2O gas both on the right-hand side. I don't want to flip my top reaction because I want to keep my H2's and O2's on the left-hand side. So I'm going to flip this reaction. And again, I multiply that by -1. Okay, so that gives me the right number of waters to cancel out. And then the only other thing that I need to do in this problem is I need to divide this reaction by 2. And the reason I'm going to divide this reaction by 2 is oh yes. Okay, now the only other thing I need to do in this reaction is actually a 2-part step. Okay, I need to get these O's to cancel out, but the problem is I've got O's in a bunch of places. Okay, and this takes a little bit figuring. Once you get better at this, this will be a lot easier. But what I'm actually going to do is I'm going to do 2 things to this reaction here. I'm going to first flip it. Okay. And the reason I flip it is it gets all of my oxygens on my O2s on the left-hand side, and this way they won't cancel out because I need them in my overall. The other thing I need to do is right now I have 1 O plus 2 O's is 3 O's on the right, but only 2 O's on the left. And I don't want to mess with this because it will affect everything else that I want to cancel. So I'm actually going to divide this reaction by 2. And the reason I divide that reaction by 2 is now that I've done this, I now have an O plus an O canceled with 2 O's. And I have 2 H's canceling with 2 H's, an H2O gas canceling with an H2O gas, an H2O2 gas canceling with an H2O2 gas, and what I have left is H2 plus 2 halves, which is a whole O2, yields H2O2 liquid. And my delta H is, of my reaction, is the delta H of reaction 1 plus the opposite sign, delta H for reaction 2, plus the delta H of reaction 3, plus the opposite 1/2, the delta H of reaction 4, plus the opposite sign, delta H of reaction 5. Do all of that. Punch this into your calculator. It's a lot. Let's go negative 241.82 plus negative 1 times negative 926.92 plus negative 1070.60 plus negative 0.5 times negative 498.34 plus negative 1 times 51.46. Do all of that, hit enter, and I get negative 187.79. Now here's the thing about Hess's Law. It's not actually hard. It's just tedious. You have to practice it in order to do it right. If you just keep practicing and keep doing the problems that I gave you, you'll eventually understand Hess's Law perfectly.